Welcome back to the MAT 1140 notes. This is chapter 7.3. We are going to solve linear equations with fractions and decimals. Now, we did a little bit of this in the last couple of sections. Going to be specific here. So to start, again, I did not leave enough space here. We're going to remove the label. We want to get rid of the times 4 and the divide by 3 part. And it's important to remember that this is the same as 4/3 times d equals 12. Now, I can divide by 4 and multiply by 3. We can also do that in one step. So when I say divide by 4, I'm multiplying by 1/4, multiply by 3. It's the same as multiplying by the reciprocal. Keep in mind, when we multiply a whole number by a fraction, we can rewrite that whole number as a fraction by putting 1 underneath. The 3/4 and the 4/3, when I multiply, I get 12 over 12, which is 1. Or I can cancel the times 3 in the numerator and the times 3 in the denominator and do the same thing with the times 4. Over on the right-hand side, because I want to make my life a little easier, I'm going to write 12 is 3 times 4. And just to be specific, this makes this 3 times 4 times 3 in the numerator. I got 1 times 4 in the denominator. Anytime we are multiplying something and it's exactly the same in the numerator and denominator, we can cancel those. I get d equals 3 times 3, which is 9. Okay. On B, I could subtract 3/4 from both sides, and that's totally legitimate. I get 2x equals 1/4. Some people do not mind working with the fractions that way. I can also clear the fractions. Sometimes the fractions are a little uglier than this by multiplying everything by 4. And why 4? Because that is my denominator. So I got 4 times 2x. And I'm doing this specifically because sometimes we end up just multiplying 4 by the parts we want, and we forget we need to multiply by everything. So my 4 over 4 cancel out. That was the point of multiplying by 4. I get 8x plus 3 equals 4. And now it's just an equation with whole numbers. 8x equals 1. Divide both sides by 8, and I get x equals 1/8. So take a minute to make sure you understand why I multiplied by what I did and whether you like clearing the fraction so that you can just work with whole numbers. Example 2. I don't know why there's an I there. Typo. We want to solve for x in the denominator, and here's the thing. We cannot solve with an x in the denominator. We need to get that out of the denominator. So just like above where I multiplied by 3 to get that out of the denominator, I'm going to multiply here by x, both sides. I want these x's to cancel. Hard to see when you're trying to cross out an x. And I get 21 equals 3x. Now I can divide both sides by 3, and I get x equals 7. Should probably make the answers a little more visible for you. Sometimes when we have an x in the denominator, it is important to consider what x could not be. So keep in mind that we cannot divide by 0. That's an absolute no-no. So whatever's going to make my denominator 0, I can't even use it, cannot be considered as a solution. So let's take a look at some of the issues that we may have when we divide by 0. When we have an x in the denominator, and make sure we are not dividing by 0 in any case. So here, I'm going to do the same thing I did a minute ago. I'm going to multiply both sides by x to get it out of the denominator, and then I'm going to go ahead and divide by 12 to get this by itself. Okay, now I get x equals 0. Look at something though really quick. If I plug in x equals 0 up here, I get 0 divided by 0. And not only are we not allowed to do that, but it definitely does not equal 12, which is what our equation says. So I cannot use this solution. So we say we have no solutions. If you get a value you are not allowed to use, bottom line is you can't use it. B, what happens when the denominator is a little more involved? So that x minus 6 represents a number. It's a number that's got to stay together. So if I am multiplying to clear that, I am multiplying everything by x minus 6. This x minus 6, whatever it is, and sometimes it helps to pick a number and plug it in. Hey, if x is 11, 11 minus 6 is 5, and I can cancel 5 over 5. I'm just left with a 15 over here. 1 times x is x, 1 times minus 6 is minus 6. Now we are solving for x. I get x equals 24. I definitely want to plug that in. 15. Why did I add 9? I did not mean to add 9. I meant to add 6. Hopefully you caught that. I'm just making sure you're paying attention. I get x equals 21. I definitely want to take that 21 and plug it back in, make sure it works. So I'm going back up to my equation here. 15 over 21 minus 6 is 15 over 15, which actually equals 1, so that works. And that one's okay. C, I got the same denominator. Instead of using x, we used b, no big deal. I'm going to put b minus 6 out here. I'm going to wrap it in parentheses to show that I'm multiplying that whole thing. On the left-hand side, I get negative 8b plus negative 6 times 8 is 48. I get 4b squared minus 24b. Notice here we have a b squared. This is something that looks different than everything we've looked at before, so we are not actually going to solve this. I am going to, though, practice moving everything to the same side because that'll be important. Sorry, bad example. We can solve for b in this situation. We are just not going to do that in this class. So we're going to stop here. Example 4, we want to solve equations by clearing the fractions. And the ones that we've done up to this part have had one fraction to worry about. Here we got a couple of different denominators. We want to make sure that we clear everything. Up until this point, I've been multiplying by one thing at a time. Here, though, I'm going to multiply by 6, but I'm going to write it this way, 3 times 2. Sometimes we forget we have different ways to write 6. And again, over 1. Not 6 over 6. That's something different. I am going to write this out. 3 times 2 times 1/3, and that's going to go under everything, so I'm just going to write it that way. Plus 3 times 2 times 1/2 x. 20 times 3 times 2 over 3. Ooh, somebody should plan better. Here, I can cancel anything being multiplied that is exactly the same in the numerator and denominator. So my 3 over 3 cancels, because 3 goes into 6. My 2 over 2 cancels, because 2 also goes into 6. And here I got 3 over 3. Those cancel. I get 2 times 1 times x, so 2x here. 3 times 1 times x, there's a 3x. 20 times 2 is 40. Add my x's because they are on the same side. And then divide by 5. X equals 8. Notice I don't have any x's in the denominator in this equation, so I'm not worried about checking to make sure 8 works. Can I plug it in and see? Yeah, 8/3 x plus 8/2 x. We can find a common denominator and reduce, and we'll get 20/3. B is a little different, so I'm going to do this in stages. 16 is 4 times 4, 9 is 3 times 3, and then I have a 3. So I don't see anything that's not super big that I can multiply and get rid of everything. So I'm going to do it this way. 3 goes into 9, so that times 9 should cancel the 3 on the right-hand side as well. Again, I am going to write this out, just because sometimes when I am talking, I make mistakes. And I know this. Plus, 70 to 85% of our intelligence is tied to our vision. The more you can write down, better off you're going to be. So what can I cancel? I have a 16 over 16 here. I have 9 over 9 here. Here I'm going to rewrite this 9 as 3 times 3, still the same value, and cancel the 3's. I get 63h plus 16 equals 3 times 16, which is 48. I'm going to subtract the 16 from both sides. I get 63h equals 32. Divide both sides by 63, and I get an answer. It's not super pretty, but it's also not one I really want to check. But we could if we wanted to. 32 over 63.